My name is Tapfumanei Mashe. I'm from Zimbabwe. Today I'm going to walk you through a presentation entitled The Power of Genomic Surveillance, and I'll share a Zimbabwean story about how we have used genomic surveillance to respond to outbreaks. So just to introduce the topic, so today I'm going to focus on cholera and typhoid outbreaks. So as you know that cholera is traced back into the 19th century, and it was first picked in India. And the current pandemic, which is circulating, is the 7th pandemic, which arrived in Africa in 1971. And of note, Zimbabwe first recorded a cholera outbreak in 1972 at a squatter camp. Then for typhoid, Zimbabwe recorded the first typhoid outbreak in 2009, around December. Then in 2010, there was a resurgence of typhoid in two suburbs, Tafara and Mavuko of Harare. So for the cholera outbreak, what happened was from 1972, we have been recording outbreaks of cholera annually, but of note is the 2008-2018 outbreaks, which I'm just going to share with you. So the 2008 outbreak was one of the biggest outbreak which was recorded, and it had a case fatality, a high case fatality, or it caused deaths of a lot of people. And the most affected areas were Budiro and Glenview, which are in Harare. So this 2008-2009 outbreak caused about more than 98,000 cases and around 4.2 deaths. So this outbreak, the response to this outbreak was, as you know, cholera is managed by oral rehydration, but also ciprofloxacin was used as one of the mitigation response to this outbreak. So after the 2008-2009 outbreak, then another outbreak was recorded, though the cases were not that high. That's the 2010-2011 outbreak, which was also recorded in Harare. Then in all this outbreak, in terms of resistance, the strains were susceptible to ciprofloxacin. So the main drug of choice, or the main drug for management of this outbreak, was ciprofloxacin. Then in 2008, we had another outbreak now, which scared a lot of people. This is the 2018-2019 outbreak, which happened around September. But of note, in March of the same year, there was another outbreak of cholera which happened, and the strain that was also susceptible to ciprofloxacin. But all of a sudden now, this new outbreak which happened from September, the strain was resistant to so many antibiotics. As you can see, when we now did sequencing, I'm also going to share the plasmid that we picked. So that's when we found that genomic surveillance is very, very important in outbreak response. So we had to do phenotypic testing of the organisms and found that ciprofloxacin was not working, tetracycline was also not working, which is also another option for cholera management, doxycycline. But all these antibiotics were not working, and of surprise was also the third generation cephalosporins. Though these antibiotics are not used to treat or to manage cholera, but what we picked was the strain was also ESBO positive. And because of this highly resistant strain circulating in 2018, we had to do a genomic surveillance, or we had to do genomic sequencing of these strains to see what was the main cause of this resistance. So I'm also going to share the plasmid that we picked. Of surprise, we picked a plasmid which had extra 16 resistant genes. Though I have showed some of the genes that we picked from the plasmid here, but I'm also going to show the plasmid. So this plasmid had extra 14 resistant genes, And the management of this outbreak, what we end up doing, though we were pushing issues to do with water and sanitation, but the solution to this outbreak was the use of vaccine. So what we did to manage the outbreak was oral rehydration, as always. Then for the antibiotics, what we end up using was azithromycin, which is the last drug of choice when it comes to cholera management. Though we tried to improve issues to do with waste management, but the ultimate solution was the introduction of vaccination as a mitigation measure, and 1.5 million people were vaccinated from the 17 affected suburbs. So I'm just going to show you the plasmid that we picked from these strains. So this was the plasmid, and these are some of the resistant genes that we picked. And from the history of this plasmid, it's a plasmid that is usually associated with cholera, but this one with additional 14 resistant genes. So that's when we found that the strain had picked the plasmid in the environment. So I'm going to share with you the typhoid outbreak in Zimbabwe, how we managed. So in Zimbabwe, I'm just going to give you a brief of the typhoid outbreak in Zimbabwe. So typhoid was first picked in 2009, as I've said before, in Mavuku. But from there, we have been monitoring the strains. And what we found was that in 2010, 11, and 12, these strains were still susceptible to ciprofloxacin, which is the main drug of choice for typhoid management. Then in 2014, that's when we first picked our first resistant strain. And this strain, we picked it in Budiriro, the same area which we had recorded the 2008 outbreak of cholera. As I have mentioned before, that for the management of that outbreak of cholera, we're using ciprofloxacin. Maybe there was selective pressure, and that's where we also first picked our first ciprofloxacin resistant strain of typhoid. So from 2014, we saw an increase in the resistance, or increased number of strains that were resistant to ciprofloxacin, from 4.6% to around 21%. And in 2017, there was just a slight increase of just 1%. But to our surprise, in 2018, where we also had that cholera outbreak, we also had a ciprofloxacin resistant outbreak of typhoid in one of the suburbs called Kwazana. And of note, this outbreak, it also managed to spread to another suburb, which is about 300 kilometers away from Harare. And there, the strains were 100% resistant to ciprofloxacin. So the drug of choice changed from ciprofloxacin to ceftriaxone and also azithromycin. But to manage this outbreak, we had also to introduce vaccination. So yes, we also managed to push issues to do with waste management, but the measure that we ended up resorting to was vaccination of people in the 9 affected suburbs of Harare, and around more than 318,000 people were vaccinated between the age of 6 to 12 months. So what we have learned for all this outbreak was that it's important to do genomic surveillance to check what is really causing resistance. So for the cholera outbreak, what we picked was due to a plasmid. And then also for this one, we have seen that it was there was a combination of two things: mutation of the chromosome, and also a plasmid-mediated resistance, ciprofloxacin resistant, which was also caused by QNRS gene. So because of all these results that we got from sequencing, we thought vaccination was going to be the best remedy, as we are going to, as we manage the issues to do with wash and the provision of clean water. So overall, what we got from these outbreaks was, it is very, very important to promote genomic surveillance, because it will help you to understand why there's resistance, what is the main driver of this resistance, and how best you can give, or how best we can employ, or how best we can use evidence-based mitigation measures, other than just to use methods that you are not very sure of. So I would like to thank you for listening. I would also like to share my gratitude